For this example, we have been asked to do a variety of things. This function is 5x squared plus 2, but we have a restriction on its domain, and that is that x must be greater than or equal to 0. One of the first things that the example asks is to determine if f of x is 1 to 1. Let's do this on our graphing calculator. So in y1, enter the function 5x squared plus 2. So go to y equals. If you have a function there, clear it out. Enter 5x raised to the second power. I have to arrow right, and then plus 2. Now, because we have a restriction on our domain being x is greater than or equal to 0, then that is actually telling us how to set our x minimum. So the x minimum would have to be 0 because that would be where our x's start. Let's go ahead and set our x max to 10, and then we can change that later if we find out that that doesn't work. And then let's do our y min at negative 10 and our y max at 10. So let's go set our window. So press window, set the x min at 0, x max at 10 is fine, leave the scale alone, and then we see that we already have our y min and our y max at negative 10 and 10. Let's go graph. Okay, seeing the graph, it looks like a half parabola. From what we know from earlier sections, we know the y-intercept is actually 2. So if we go up to 2 and plot, then it would be a half parabola-shaped graph. Now, I'm putting a closed dot specifically at x is 0 because of the restriction on my domain. Okay, I can have it be 2 specifically at 0, but I don't have anything to the left of that amount. So this is my function f of x. It's my original. Now, make a note about the domain of f. The domain of f was restricted from 0 to infinity. What's the range? Well, because we knew the y-intercept was 2, the range of f is everything from 2 to infinity. Now, without actually graphing the inverse, we know that the domain of the inverse is the range of the original. So it would be from 2 to infinity. And then the same thing on the range of the inverse. The range of the inverse is the domain of the original. So it would be from 0 to infinity. We have actually also been asked to graph f of x and its inverse on the same set of axes. We have enough information at this point to do this. We know that they are reflections across the line y equals to x. We also see that this particular original function has a y-intercept of 0, 2, and so the inverse would have a x-intercept of 2, 0, and then this basic shape. So I'm going to label that as the inverse. We use the f to the negative 1 notation to denote an inverse. Okay, then finally, the question asks, if you have something that is 1 to 1, find a formula for its inverse. Notice here that if we draw a horizontal line through our original function, it crosses only once, meaning that the original was 1 to 1. So we will say the original is 1 to 1. I'm going to box that in since it's part of my answer. Okay, we have the graph of the two functions, so that is part of our answer. And then we've been asked to find the domain and range of each, so we have that. And then finally, it wants the formula for the inverse. Now, I'm going to make a note. If x is greater than or equal to 0 in the original, then when we take the inverse, y must be greater than or equal to 0 in the inverse. We know that inverses means that you just switch x and y. And so if they tell us originally that x's were supposed to be greater than or equal to 0, then in the inverse, y's would have to be greater than or equal to 0. Okay, this is important because of one of the steps that happens when I'm trying to find the inverse. On here, the first thing I want to do is write down the original function. The original function was f of x equals 5x squared plus 2. In place of f of x, that's the same thing as y. So we actually want to rewrite the original as y equals 5x squared plus 2. Now, when we find the formula for the inverse, we switch x and y. So where the y is, we put x, and where the x is, we put y. Now, to finish, we need to solve that equation for y. So we would subtract 2. We have x minus 2 equals 5y squared. I'm going to divide the 5 out, and what I'm going to do on the left-hand side is divide the entire side by 5. And then on the right side, I'm left with y squared. Now, I like to have my y's on the left, so all I'm going to do here is rewrite or reorder so that I write it y squared equals x minus 2 over 5. Now finally, to solve for y, I need to take care of the square that's on the y. To do this, I would take square root of both sides. Because my root is even, I have to put a plus and minus on the right-hand side. The root is going to cancel the square on the left, and I'll be left with y. And then on the right, I have to choose either a plus or a minus. Now notice that the left-hand side is y. What did we say about y? Y had to be greater than or equal to 0, meaning that our y's are positive. I cannot have two values for y down here. I cannot have a plus and a minus. So in the problem somewhere, it had to indicate to me which one of the two am I going to choose. I'm going to choose the positive value because I was told that y had to be greater than or equal to 0. Okay, this being the case, I now have the formula for my inverse. However, I need to write inverse notation, so instead of writing y equals, I would write f inverse of x equals square root x minus 2 over 5. And I no longer really need to write the positive sign. It's understood to be positive when I don't write it.